Hi there and welcome to my channel. In this video, my topic is changing the subject of the formula, and it's sometimes called transposition. It's rarely taught in Form 3 or maybe Form 4, but it's carried forward in all the upper forms. It's done in math usually, but it's used in AdMath. It's not taught in AdMath, but it's used there. So I have a few worked examples, so I hope that you all could stay tuned with me so that we could see all the different methods on how to transpose, because each one is different. Okay, so what does transposition mean? Transposition, or changing the subject of the formula, simply means we are changing the variable that is there by itself, right, on one side. Now, right now, this v here is by himself on this side. So v is the subject of the formula currently. However, they could ask you to change the subject of the formula to any variable here, u or t. So this in brackets tells us that they want us to change it to t being the subject. So then what does that mean is that I need to kick out everything else that is on the side with t. Now what is on the side with t is simply a u, and this u is being added to t. So if I want to send this over here, I will have to take away u. So my next line will be v minus u is equal to t, which is actually my answer. So this is the end of my first example. In my second sum, y is the subject here, and they ask us to transpose for x, make x the subject. Now, before you jump into starting to do things and send over, you need to analyze your sum. So in this particular case, I have a 2 being multiplied by the x, and then I have a 4 being taken away from this product. So the first thing I want to do, guys, is send over the 4. The minus 4 will jump over here and become plus 4. So that's this line. The last thing I want to do is send over this 2. This 2 is being multiplied, so when I send it over, it will then divide. So then I'll end up getting y plus 4 all over 2 is x. Now, believe it or not, that's your answer. Another way of writing this is you could usually break this up into two fractions. You'll end up getting x is equal to y on 2 plus 4 on 2, which is y on 2 plus 2. Or you could write it back just like that. X is equal to y plus 4 all over 2. So either one of these are correct. So this is my third one. And we need to make g the subject of the formula. Now the first thing I told you, analyze. Where's my g? G is here, and it's actually the denominator. So this is pretty simple. It may look a little complicated, but what's going on here is I have one term here equal to another term. I don't have like a plus 4 or anything like that, right? Now, if I did have that plus 4, it will make the sum a lot more complicated. So because I just have one term equal to another term, I could simply swap these values here. So let me show you with some colors. The values here and here I could swap. So literally, I could take this g from here and bring it here. So I could write g alone. I could write back my 3d. I could write back my r at the bottom here. And all of these here, 4xy, I could just write it here. So this, everyone, is my answer. Now, the only time I could do this is if I said I have one term here equal to another term here. If I have anything on this side or anything as well on this side, add in or minus in, I cannot do this. So this, everyone, is my third example. So in my fourth example, I have this, and I want to make h the subject of the formula. Again, analyze. My h is one of two terms here and here, and h is my denominator. So what I need to do is I first should send over this L here, which is adding. So I'll get u on x minus L is equal to m on h. Now, because my h here is at the denominator, and I have a fraction here and another value here, what I want to do before I send this over on this side here, I need to make these two values here one value. So how do I do that? By LCM. So LCM here would be x. X into x is 1. 1 by u is u. 1 into x is x. X by L is Lx. So now I have this line here. So now at this point, I could cross multiply, meaning the denominator here will multiply by this, and the denominator there on the other side will multiply by the other side, right? So h will multiply by u minus Lx, and m will multiply by x. Now I'm very close to my answer. I need to get h as my subject of the formula, and right now I have h multiplied by this whole expression here. So what I should do is just, since it's multiplying here, I'll just divide. So my next line will be h is equal to mx all over u minus Lx. So I changed this operation here from multiply to divide, everyone. Right? Now nothing in my expression here changed. My u minus Lx is the same u minus Lx. It doesn't change to positives or negatives because I have already changed the operation from multiply to divide. So this is the answer. So my fifth example looks a little complicated. I have a whole set of stuff going on. I have a square root, I have a fraction, then I have a fraction within a fraction, right? And I need to actually get t as the subject of the formula. That's this little t here, right? So the first thing I want to do is I want to break it up. Now, t is the denominator of this small fraction, and that small fraction is also the denominator of this bigger fraction with the big T, right? So the first thing I want to do now, this is k multiplied by the root of all of this. This is not root k, right? So we need to differentiate that because root k is different. So k has been multiplied here. So the first thing I do is send it over. So I get v over k is equal to root of t on s on t, right? So the next thing I send the root, this root here. So sending over that root makes well, of course, the opposite of that is squaring. So it makes this side square. So I get that, right? So which is equal to this, right? So now I need to I need to figure out how to get the small t on this side, or on any side, but let it be by itself. Now the best thing for me to do here is to cross multiply. So cross multiplying now will give me this. St will multiply by v squared, so I'll get st v squared is equal to capital T by k squared, right? So nice. I have a fraction here equal to one value, and t, the value that I want to make the subject of the formula, is the denominator. So again, this is just like example 3, I think, where my value is a denominator and I want to make this a subject, so I can simply just swap these two. So I write SV squared over T K squared is equal, capital T K squared is equal to common T. So this, everyone, is my answer. Example number 6. I need to make D the subject of the formula. Right now, D is a denominator, however, there's a square on it. So once there's a square, the opposite of squaring is square root. So easy thing to do, swap these two. D squared, is equal to 1 on E. No, am I writing K? Sorry for that. D squared is equal to 1 on E, and then the square root, sending over the square would be square root. So the square root of this side would be all of this. 1 on E. That's it. This is the answer. So in example 7, we need to make f the subject of the formula. F is already on one side, yes, but f is the denominator here. It's not f over 1, it's 1 over f. So no, we don't like this. So we can't just flip this and flip everything on the side. No, it doesn't work like that. Because if you're looking at an example, say 2 plus 3 is equal to 5. If I flip the 5 and got 1/5, is that the same as saying, a half plus 1/3 is equal to 1/5? No. So you can't do that. You can't just flip this, and flip this, and get your answer. No. And get here u plus v is equal to f, and that's it. Nope, nope, nope. That wouldn't work. So what we need to do instead is we need to find the LCM here. So the LCM here will be uv. U into uv is v. V by 1 is v. V into uv is u. U by 1 is u. So now I have this. Now I could cross multiply. Right? So I'll get f by u plus v. V plus u, doesn't matter, is equal to uv by 1, which is uv, right? And then f is equal to uv over v plus u. So please remember, right, guys, you cannot use this method here, which is just to invert each value, this value, this value, and this value, and get the answer, right? This question here, even though it looked simple, it required a lot more work. So this is my 8th and final example. And this example, it's a little tricky. It's one where we have to find the subject of the formula being f, and f exists 2 times, here and here. Now, whenever you have a variable that exists more than once, that's okay. Once the powers are the same, this is f to the power of 1, f to the power of 1, right? So that could work out. If they were different, it'll be a little trickier. Actually, it may not even be possible. So firstly, once we know that f exists more than once, we know somewhere along the line we need to factorize for f, right? So let's move on. How do I do this now? Well, I could just simply send this whole denominator here, multiply by g. So I'll get this. Then I could expand this. I'll get gf plus g is equal to f minus 1. And then from here now, I could bring across all the f's on one side. So this could go here and this could go here. So I get gf minus f is equal to, what's that, minus 1 minus g. So f by g minus 1, I'm factorizing here, right? Because I want to get one f, right? By factorizing, I get one term for f. Otherwise, if I'll be left with two terms for f, and that's kind of hard to transpose for f. So my last line now, guys, this is g minus 1 here multiplying by f. I just simply, well, it's multiplying on this side, so I just simply send it over and I divide. So I get f is equal to minus 1 minus g all over g minus 1. So this, everyone, is my answer. Okay, so I want you to know that while this is the answer, this is not the only answer that could happen for this. When you're factorizing, there are two options, right, in transposition. So this line here, I sent over my plus g over on this side and my f on this side, which gave me this line here, right? Now, what if somebody did the opposite, meaning they had the same line as me, and they sent the minus 1 over by the g and the gf over here. So then they'll get g plus 1 on this side is f minus gf. So you get g plus 1 nicely here, factorizing this side now, gets this, and then hence their answer would be g plus 1 over 1 minus g. So this will also work as an answer. So all I'm trying to tell you guys, whenever you need to factorize and say you get one answer here, like say this is your answer, change up the signs if you wish, if you need to check behind the book to see your answers. So this minus 1 become a plus 1, minus g will become a plus g, this positive g at the bottom here become a minus g, minus 1 will become a plus 1. And in case you're checking the back of the book and you're not seeing your answer, but you're seeing this answer instead, this answer here, just know that by converting each value here, you can get the answer. So, point to note, factorization with transposition can give you two answers. Okay, so everyone, I'm now complete. I did 8 worked examples. Each example focused on a different aspect of transposition. I hope that you'll understand. I hope that it's a lot clearer now. Now, I know that I did not give a note on this, but it's really because each one was different. And usually I look at my questions and I try to figure out, what am I really given here? What is going on? And then I try to figure out, okay, well then what I need to do. So please, feel free to like, share, and subscribe. Thanks guys for tuning in.